So we've just seen that when we have a series circuit, if one module isn't working or is, for example, covered, then only very low output values are actually produced. That is not good. So what kind of solution can we possibly find for this problem? For that reason, we will now explore the parallel connection to find out if we can generate more electricity, even if some modules are not functional. So, first we're connecting a parallel circuit here. To do that, we'll undo our series connection. All red cables must go on the red side and all black cables on the black side. The diagram on the base plate illustrates that. We plug in the red cable that comes from this module right here, and the red cable that comes from the other module we also plug into the red socket. And the black one also goes into the black side. The other black cable goes into the black socket next to it. And then, for this setup, we will also require another black cable, which is going to connect these three specific jacks, which are already interconnected with one another from this exact point over to the resistor. Now the current flows through the resistor. And then, on the other side of this setup, it's necessary that these three jacks are also connected to the other side of the resistor. So, what this means is that the current flows right through the red cable here, and then it goes into these three red jacks, where it's then connected to this component, and then it passes through the resistor. On the other side, it is connected with these black cables, from where it then flows back into the main module. So what we have here is essentially a parallel circuit. So, as a first step, we're going to measure the terminal voltage of both PV modules. We will measure the terminal voltage once before the module and once after it, and this will be done for both modules. How will we do that? First, we'll need to grab two additional cables. We take the red cable and connect it under the cable that comes from the first module, in order to connect them together, and then plug it into the multimeter. Now we take the additional black cable, and the black cable that comes from the first module, that's the one we are currently measuring. We connect them together here, and we also insert that into the multimeter. So it starts from the red one, goes in here, goes into the multimeter, and then it goes through the black cables, and voila, we have our closed circuit as intended. What we do now is we adjust the multimeter because we want to measure the voltage. We set it to volts, in this case to 20 volts. After we have set up everything, we can note down the values that we measure. As a next step, we will measure the second module's terminal voltage. For that, we'll first unplug this here, and we'll do it again following the same logic. So now, from the second module right here, the red cable goes out, and then it goes over here. And then we plug them together and plug it into the multimeter. And the black cable from the module, this one, it connects right here, which means we simply plug them together and plug it into the multimeter too. And now we'll note the value down again. So we have now measured the individual terminal voltages of each module, and now we can proceed to measure the total voltage. To do that, we'll unplug everything once more. So for measuring the total voltage, we are taking this red cable and we'll plug it in underneath the cable that comes from the first module and then connect it here to the multimeter. And the black cable, the one that extends from the second module, to be precise, this one right here, we will now plug in the other laboratory cable underneath it. And we're going to plug this into the multimeter now. We'll also note down that value. So, in the next step, we continue with the electrical current. So, next, we want to measure the current in the parallel circuit. For that, we'll first measure the current in the first branch. So now we take the red cable that goes from the first module and plug it in. After that, we'll take the red cable that comes from the first module and plug it into our multimeter. Now we need a second cable and we plug it into the three-way connector where we previously removed the cable. We still need to turn it on. Then we can note down the value. Exactly the same procedure we will use to measure the second branch. This cable can stay plugged in and we take the cable that comes from the first module and replace it with the one that comes from the second module. Let's note down that value. Now we have measured the current in the two branches, so we still need to determine the total current in the parallel circuit. To measure the total current, we need to connect the cable that's located before the resistor, this one here, to our multimeter. Then we need another cable, which we will plug from the multimeter before the resistor. And we'll note down this value as well. So what we just measured was the total current in the parallel circuit. All right, now we will have a look at how covering one PV panel affects current and voltage. For the next step, you can leave the setup just like it is. What we will add now is the total voltage. For that, you plug a black cable on top of the lab cable that is in front of the variable resistor and plug this into the multimeter, and on the other side, connect the other cable to the resistor and also put it in the multimeter and then set the multimeter to voltage. So now we have the total current here on the multimeter, and on the other multimeter we have the total voltage. So now we turn our light on again. And now we can look at how the two solar panels behave in parallel connection when, for example, one is broken or covered by something. But first, let's note down the values. We take our cardboard again and cover one of the two panels. So the values we are seeing now, let's note them down as well. And next, we can cover the two halves of the modules at the top. Let's note these values down as well. We just discovered how the current and voltage change when we cover one module. So for example, if in reality one of the modules is defective or dirty, or if a cloud is covering it. Now let's ask ourselves, what do we learn from the values that we measured? Since the current adds up in parallel circuits and the voltage stays the same, the voltage also remains unchanged if, for example, one of the modules is defect or not fully functional. On the other hand, let's have a look at the current. If one of the modules is defect or isn't fully functional, then the current is smaller. The current is reduced by as much as the module produced. Actually makes sense, right?